Okay, so today's lesson for 3B is about vertical and horizontal asymptotes. When we can find those discontinuous points using those tables of signs that you were looking at last lesson, the zeros, the discontinuous points, usually represent asymptotes, the vertical ones. But we also need to find the horizontal ones as well. So we're going to look at some techniques on how to find them, and then that together is going to build towards being able to graph things hopefully a little bit more easily, some more complicated graphs. So to test for a vertical asymptote, this is what we should do. First of all, you should factorize your function. If the denominator has a value for x that will make the denominator equal to 0, then that is going to be a vertical asymptote. Then we're going to draw a table of signs to identify the behavior of the curve on either side of that asymptote. Okay? Then to test for horizontal asymptotes, again, the function should be factorized, but we'll already have done that. But we want to divide the top and the bottom of your fraction by the highest power of x that is on your denominator. And that helps us work out what is happening as our graph is going out for very big values of x or very small. So the plus infinity or minus infinity, what's happening out for our very big values. Then use the fact that 1 over x is approaching 0 if we're putting in a value for x that's approaching infinity. Okay, because you can imagine if it's 1 over x, if x represents infinity, 1 divided by a really massive number is going to be approaching 0. And that's why we divide through by our x's to give us those fractions. And if f of x tends towards a definite limit, such as some value b, as x approaches infinity, or as then the horizontal line, we'll have a horizontal asymptote at y equals b. Okay, let's do it. Question 1. Consider y equals minus 2 over x minus 4. And part A is going to break it all down into steps for us. Part A, write down the domain using both interval notations. So first of all, to work out a domain when you have a fraction in your equation, you're looking at the denominator. We know that the denominator cannot be equal to 0, which means that x cannot be equal to 4, because that would make my denominator 0. That is how we would normally write it in our normal interval notation. But if I had to write that in the bracketed interval notation, we have curved brackets because it cannot be at the 4. And it could be any value less than 4. So I would say from negative infinity all the way up to 4. And remember that we use a curved bracket around infinity as well, because that's not a finite number. Or, so using our or symbol, it could be any value above 4, curved bracket, starting at 4, going all the way up to infinity. Okay, which is a very complicated way of saying anything but 4. Okay, but that's how you have to write it. Part B, test whether the function is odd, even, or neither. Okay, it seems like, that's just a bit of algebra practice things that we learned about in our year 11 content, but it can be very useful when you're sketching your graph. If you know it's going to be symmetrical, it's a pretty good clue if it's going to be looking right at the end. Okay, so to test if something is an odd or an even function, you always start by substituting in f of minus x. So into my function up here, I'm going to replace the x with a minus x. So it's be negative 2 over negative x minus 4. Now I could take a negative sign out of my denominator. So it'd be negative 2 over negative x plus 4, and that means that I could cancel the minus from the top and the bottom, giving me 2 over x plus 4. Now, if you do all of that and you end up with the exact same function as the original one that I've highlighted in yellow, then it would be an even function. Mine is not the same. If you can factorize a minus sign out of it, so let's try that. If I try to factorize a minus sign out of that, so I put a minus out the front, that means I'd have to put an extra minus in the top, but it would still be an x plus 4 on the bottom, which is not the x minus 4 that I need. So unfortunately, it is not going to be odd either, because odd means I should be able to bring a minus sign out of it, and what is left in the brackets should be the same as my original function, but it's not. Okay, so this means therefore that my function is neither. It is not odd nor even. Part C, find any zeros and discontinuities and construct a sign diagram. So you know the difference between a zero and a discontinuity? Do you know a difference? So a zero is the x-intercepts of your graph, where it's going to cut through the x-axis, and the discontinuities is where there is a break. The graph will go to one point, it will break, and it will start again somewhere else. Usually for us, that's going to be over an asymptote, where we're finding those. Okay, and then we're going to be constructing a sign diagram. So our equation, y equals minus 2 over x minus 4. To find the zeros, you're looking at whatever's on the top of that fraction, and it's whatever makes the top of your fraction 0, if you can sub in an x value to make it 0. There is no x's there. My numerator is always going to be minus 2. So it's not possible to make the top of that fraction 0, which means that there is no zeros. There is going to be no x-intercepts for that graph. The denominator is where we get our discontinuous points, when that is equal to 0, and we've already kind of mentioned that. Discontinuous, because we looked at that at the beginning with our domain. Whatever makes that denominator 0, which is going to be at 4, that is my discontinuous point. So discontinuous at x equals 4. Bit repetitive there, doing that again. So the table of signs has 3 rows. The first row is your x values, second row is your y values, and the third one is the sign of the y value. And we only have one x value that we're really looking at here, which is 4, because we have no other zeros or any other intercepts to look at. So I only need to have 4 in the center of my table, and I need to test a value on either side of it. So you can choose whatever you want. It's nice to make things easy for yourself, so 0 is a nice one to sub in. What did you say? 5?
3.14.
Oh, okay, I'm keeping things simple. All right, so I'm just going to keep it symmetrical. Since I went 4 down, I'm going to go 4 up the other side. So 0, 4, 8 is what I'm going to do. But it could be anything on either side of 4, all right? 4 itself, because it is a discontinuous point, you don't need to. You can if you're in doubt. You don't need to sub that back into your graph, because you know that that's going to give you a denominator of 0, which means that's your asymptote. So we put a little asterisk in there. There's no values there. Now I'm going to sub into my calculator 0. So you just type it in. We go minus 2 over, we're subbing into our equation, 0 take away 4. And I get a half. And more importantly, that half is positive. So I put a plus sign down to say it's positive. Then I just want to do it again, and I just want to change that 0 to an 8, and I get negative a half, which means it's negative on that side. So that's my table of signs. Now we're going to use that to help us with the next little bit. Part D says, find the vertical asymptote and describe its behavior around it. So we're repeating it again. That vertical asymptote is where? At x equals 4. Okay, so when x equals 4, there's my asymptote, but I want to be a little bit more specific now about what is happening around that asymptote. So I want to see what's happening as x is approaching 4 on we put a little minus sign up here saying just slightly to the left of that asymptote. That means just slightly smaller than that 4, what is happening. And I also want to do as x is approaching 4 with a plus sign, which means just slightly on the right. Now, we can use our table of signs to help us do this. If I look at my 4 in my table of signs, as I go on the left-hand side of it, my value is positive, okay? And it does mean that my function, my f of x, or I could call it y, but my function is going to be approaching a positive infinity. Now, I only subbed in 0, so half doesn't look like it's actually going to infinity, but the fact that it's positive is helpful. If you want to choose a value much closer to 4, you would get a much bigger result. So you could sub in 3.9. Okay, I've still got here on my calculator. Let's go back in here. And I could sub in 3.9 equals to 20, getting quite a lot bigger. Or let's go 3.99, and then we go already up to 200. So the closer and closer I put it to that asymptote, but just slightly less than it, that is going to get massively big, okay? If I want to approach 4, but on the positive side, okay, I'm on the right side now, I notice my values are now negative, and what do you think my function is going to be approaching? Negative infinity. So f of x is going to be approaching negative infinity. Feel free to always sub stuff in if you're in doubt.
And is it wrong if you say as x approaches 1, f of x approaches plus or minus infinity?
As x approaches 1?
4.
Oh, you said 1. So x approaches 4?
F of x approaches plus or minus infinity.
Yeah, because I'd need to know which side. So I want to know, because when we do get to the part where we're sketching this, I want to know when I'm on the left, I'm going to be it's going to be on the high side. I need to know which one relates to which, you know what I mean?
Okay.
So please separate them. Okay, E, find the horizontal asymptote and describe their behavior near it. So a horizontal asymptote can usually be found by working out what happens for really, really big values of x and really, really small values of x. Because what's happening way out here as my curve is going out a long way, right? So I'm going to be finding as x approaches infinity, really big values of x, and as x approaches negative infinity. Now, we were told to, in the instructions at the beginning, if I have a function which was y equals, writing it down again, minus 2 over x minus 4, that we want to divide through by the highest power of x that is on the denominator. So my highest power of x is a power of 1, x to the power of 1. If I divide...
The power of 1.
There is a movie called The Power of 1. Thank you.
So random.
She just wanted to feature on the video, I think. If I divide the top, it looks messy to do this, but I'm going to divide the top by x, so it's going to be minus 2 over x, and I'm going to divide each term on my denominator by x as well. So x divided by x gives 1, and minus 4 divided by x is just minus 4 over x. So as I sub in infinity, my function f of x is going to be approaching, on my numerator, if x is infinity, 2 divided by infinity is basically going to be 0, right? A number divided by something massive is going to be getting super, super small. It's going to be approximately 0. On the bottom, this fraction here is also going to be approaching 0. So I really just have a 1 on the bottom, correct? Okay, so it's 0 over 1, and 0, as long as there's not a 1 on the bottom, a 0 on the bottom, then 0 divided by anything means that that's going to be approaching 0. And we can do a similar thing for negative infinity. Now, if you sub in negative infinity, this is still approaching 0, and this is still approaching 0, so it's still 0 over 1, so that's going to be approaching 0 as well. Now, one of the things that can mesh with your mind a little bit here is how do I then do the little plus or minus signs? Which side is it going to be on, Ashton?
What if the x turned into a 1?
Because I was dividing everything through by x, so x divided by x is 1. Yes? Okay. So for some equations, you can, it's really tricky. You can kind of try and go, all right, if this is a negative, really small number, and 1 minus a really small negative number, will it be positive or it gets too messy in your head? So this is what I do. It might be a little bit of a cheat. I feel a little bit bad saying this, but this is what I find easier to do. If I want to know if my graph is going to be slightly above or below that asymptote that I've just found, I sub in a value. Okay, so I'm going to, for my fraction, which is -2 on the top, and I'm just putting this into the x minus 4 on the bottom. As x is approaching infinity, I'm just going to pick a number like 100. 100's big enough. 100 minus 4. Okay? So that number there is approaching 0 as expected, but it is negative, meaning it's just slightly below that 0, which means I put a little minus sign up there saying my graph is going to be slightly below that asymptote at that point. And if I wanted to do it for the negative infinity, let's just make that a negative 100. Okay, and now, still really close to 0, but I'm slightly above 0 now, which means that's approaching 0 on the positive side. Okay? All right. So my horizontal asymptote, maybe I should write that as a conclusion, therefore horizontal asymptote at y equals 0. Okay, part F, sketch all that information on our curve.
Couldn't you just make it as y approaches 0?
Yeah, you could, definitely. Yep. Okay, so what was the first thing we worked out? Okay, I've got it on my notes, so I have to keep scrolling backwards and forwards. So sketching our curve. First thing I found was my discontinuous point, which we knew was a vertical asymptote, at 4. So here at 4, I'm going to draw a dotted vertical line. And to have everything correctly labelled, you're going to put VA for vertical asymptote at x equals 4. Okay, then we worked out that there was a horizontal asymptote, I might do that in red since it's going to blend with my axes otherwise, at 0. So that is a horizontal asymptote at y equals 0. Now my table of signs, remember that I chose 0 as one of my values, which is always a good option to choose, because when it comes to sketching a graph, that tells you your y-intercept. Okay, so looking back at your table of signs, when x is equal to 0, y was equal to a half. So it's going through there at a half. Now comes all the stuff around the asymptotes. Let's start with the 4. As x was approaching 4 on the negative side, which means just slightly to the left of that asymptote, my graph is up at positive infinity. It's up here somewhere. And as x is approaching 4 on the positive side, it is down at negative infinity. It's down here. So see how I'm just got slightly on either side of that asymptote. Now let's check out our horizontal asymptote. As x is approaching infinity, which is way out here to the right, then my y value is approaching 0 on the, it says on the negative side. Oh yeah, that's right, on the negative side, where it didn't work there for a second. Yeah, on the negative side, so it is just slightly below. Okay, and that is enough. This is only, it's not a really detailed, accurate sketch. We join that up, we're going to have a curve coming around like that between those two values. And then checking the other side, as my x is approaching negative infinity, my y value is approaching 0, but on the plus side, which is up here, which you probably could guess from my intercept as well. So it's starting up high, coming down through my intercept, oh, that was a bit messy, and coming way down super tiny. Try to make sure that your graph does not ever look like it's going to curve back away from your asymptotes. Okay, it's meant to keep looking like it's coming closer and closer. They can actually deduct you marks, which mine could almost, I better draw that better, because I could almost lose marks for that, because my my curve almost looked like it was going to come back up, so it might be better to stop there so it doesn't even look like it. Okay, does that make sense? All right, let's do question 2. Practice it all again. We're going to be repeating the same steps over and over a lot today. Question 2. A new graph, y equals x minus 2 over x minus 3. What is the horizontal asymptote? We're just doing things in a different order here. The horizontal asymptote, remember, is we want to see what is happening as x is approaching positive infinity and as x is approaching negative infinity. Okay, so before I do that, I need to come back up here to my equation and I need to divide through by my highest power of x that is on my denominator, which is just x to the power of 1 again. So dividing everything, x minus 2, so the x divided by x is going to be 1 minus 2 divided by x. On the bottom, x divided by x is 1 minus 3 divided by x. Okay, so now when I put in there that x is equal to infinity, okay, this part here is basically 0 and this part here is basically 0. So I have 1 over 1. You can write it down if you would like a bit more detail. So y is approaching 1 minus 0 over 1 minus 0. Oops, that should be a minus sign. Okay, so that's approximately 1. Is that going to be above or below that 1 though? We could check it by subbing something into our calculator. So let's type in the fraction. If I'm going out to infinity, let's use that 100 number that I like. 100 minus 2 over 100 minus 3. Okay, and that is 1.01, so it's close to the 1, but it is slightly above it, so it means it will be on the plus side. Okay, now for negative infinity. So same deal, those fractions are basically going to be 0, so it's going to be 1 plus 0 over 1, so I said plus, that should be minus, 1 minus 0, 1 minus 0, not that it matters when it's 0, which is again going to be equal to 1. And if you changed all those positive hundreds to negative hundreds, do you need me to do it? Or is that going to take too long? It won't be the same? Oh, okay, I'll do it. 0 back in, minus 100 there, minus, whoops, there. So that is slightly below the 1, isn't it? So it's just below the 1, minus sign. Yes, making sense? All right, part B, or actually wait, let's just put a little conclusion there. So that's a horizontal asymptote at y is equal to 1, and we've seen where it is slightly above and slightly below. Part B, find any vertical asymptotes and examine their behaviour near them. So the vertical asymptote is to do with the denominator, okay? So it's also called our discontinuous point. So discontinuous at whatever's on the bottom, the x minus 3, whatever makes that 0, which of course is going to be when x is equal to 3. There is actually a 0 for this graph while I'm investigating my denominator. The numerator. What makes the numerator 0? Yeah, so there's a 0 at x equals 2. There will be an x-intercept this time. Okay, now let's investigate our vertical asymptote. So as x is approaching 3 on the plus side, and as it's approaching 3 on the negative side. Okay, we can do this from our table of signs. That was the instruction from the beginning of the lesson. So let's stick to that. So our x, our y, and our sine. Okay, so I have got a 0 at 2 and a discontinuous point at 3. So I'm going to put 2, a space on either side of 2, and then I'm going to have 3 and a space on either side of that. So you can see what's happening between each of those things. So let's choose 0 because that will give me my y-intercept. Between 2 and 3, I think 2.5 is the obvious choice. And then larger than 3, we'll choose 4. Now, x is equal to 2 was my 0, so I just put a 0 and a 0 there. It's called a 0 for a reason. Y equals 0 there. The x equals 3 is my vertical asymptote, or my discontinuous point, so they have the stars, the asterisks. If I sub 0 into my equation, I get 0 minus 2 over 0 minus 3, which will be 2 over 3. If I sub 2.5 into there, do you mind if I just tell you the answers to speed this along a little bit? So that's minus 1. And if I sub 4 in, we get 2. The important thing is that the 2/3 is positive, that one's negative, and that one is positive. So looking at my vertical asymptote, the 3, this one here in the middle, if I am just to the left of that, when it's smaller, my sign is negative, so it's going to be approaching, my y value is going to be approaching negative infinity. If I am to the right of that asymptote, the plus side, then my values are positive, which means we're going out to positive infinity. Okay, can do it from the table of signs. There's enough information there to do that, or feel free to sub in closer values if you're concerned still. And finally, we can sketch the curve. We have all our info now. So start with the asymptotes. Hopefully it's a nice, neat sketch. All right, we had a vertical, no, we started with the horizontal asymptote at y equals 1. So HA for horizontal asymptote at y equals 1. Our vertical asymptote is at x equals 3. 1, 2, 3. I'll put a 3 there and a 1 there. So VA at x equals 3. We did find our y-intercept. When x was equal to 0, y was equal to 2/3. So about there. Okay, so I'm going to put a little arrow in there and say that's the value 2 over 3. All the little investigating that I did, let's start with that. When x was approaching positive infinity, y is approaching 1 on the plus side, so slightly above the 1. As it was approaching negative infinity, I was approaching 1 from the smaller side, so slightly below that asymptote. As I was approaching 3, x was approaching 3 on the plus side, y was approaching infinity, so the plus side is the right. But when I was approaching from the smaller side, I was down here at negative infinity. So on this side, oh, I can't see where I'm drawing through there. It's going to come up and around through here. A little bit wobbly. Should be a nice curve, not as wobbly as mine. I can, on the other side, it is going to come around and connect up like that. Depending on the question, they may ask for an extra point on there to show the steepness of that one on the other side. If you needed to, you could well, we actually found one. We've got 4, 2 here, don't we? We've got 4 and 2, which means that point there would be another point we could put on that side if we wanted to show that steepness. And where is, oh, mine's a really bad graph here. Where is my x-intercept? It's 2, yeah, I need to show that. I've got to draw that better. Should be coming over here through 2. Because we found that. So that should be going through a 2 in there. Okay, so try wherever possible to show your intercepts and maybe steepness of the other little part if you can. All right, question 3. Yes, another one more. The good news is that none of these ones involve sketching. All right, question 3. Make it a little bit faster. Examine the behavior of the following function as x approaches infinity, as x approaches negative infinity, noting any horizontal asymptotes. Okay, so this is just practicing with those horizontal asymptotes because that's the newest concept here. So the first thing that we do is we divide through by the highest power of x on the denominator. What's my highest power of x? X squared. So I'm going to write that next to here as a reminder. You wouldn't write this on your test, but if you're looking back at your notes, it might be helpful. I'm going to divide by x squared. Okay, so on the top, x divided by x squared would be 1 over x simplified. And 2 divided by x squared, unfortunately, doesn't simplify, so it's just 2 over x squared. On the bottom, x squared divided by x squared is 1, and minus 9 divided by x squared. Okay, so by doing that, we're ready to test for our asymptotes.
Can you simplify the 9 over x squared to just 3 over x?
No, you can't square root the 9. No. As x approaches infinity and as x approaches negative infinity. I'm going to get used to doing this. So as x approaches infinity, all of those fractions, the 1 over x, that's 0. The 2 over x squared, that's 0. And the 9 over x squared, that's 0. The only number that we have in there is the 1 on the denominator of that fraction. So I have 0 on the top over 1, which is just going to be 0. Y is approaching 0. Now this question I don't think actually asks me, because I'm not drawing this, I don't really need the little pluses and minuses on there. If you wanted to find them, you would sub in a really big number like 100 into there. You go 100 plus 2 over 100 squared minus 9. And it does work out that that one's on the plus side. Okay, you do that by testing some values if you needed to, or you could draw up your full table of signs or whatever if you want. All right, if you put in negative infinity, then it's also going to be approaching 0, and that would be on the negative side if you subbed in negative 100. But the plus or minus I've probably done more than the question actually asked me to do. I was just doing that as an extra. The only thing I was really after here is where is my horizontal asymptote? It is at y is equal to 0, because both ways that I checked it, it was always approaching the 0. Okay, that one's done. Let's do B. Divide through by the highest power of x on the denominator, which is just x. Don't worry about the higher power on the top, it's always about the denominator. So I'm dividing by x. So x squared divided by x is x, minus 2 divided by x. On the bottom, x divided by x is 1, minus, and 5 divided by x. Okay, again, as x is approaching infinity and as x is approaching negative infinity, what is going to happen? So at positive infinity, this is 0 and this is 0, but that is infinity. Okay, so that's like infinity over 1. So it's actually approaching, my y value is approaching infinity. Probably not what we were expecting. It's usually a nice number there. If I put in negative infinity, that's 0, but this is negative infinity over 1. So that is going to be y is approaching negative infinity. Okay, so that actually means that because they're two different y values that graph is approaching, there is no horizontal asymptote. They should be approaching the same number if there is. So write a little conclusion there. This graph does not have a horizontal asymptote. Now, just for fun, what does it have? I sketched it for you on Desmos. That is what the graph looks like. It has a diagonal, a sloping asymptote, and this almost broaches on extension work, definitely not advanced stuff. That line that's approaching down there would be y is equal to x, because it was the x that was left in my equation when I had all the zeros and everything else in there. Okay? All right. But anyway, that was just a little bit of interest in there. We weren't asked to do that. So let's get back to our next question. Come back. There it is. All right. Next one, C. What am I going to divide by?
X cubed. X squared.
By x squared. The highest power on the denominator is an x squared. So it will look pretty messy. I will have 2 over x squared minus 3 over x, because an x on the top and bottom will cancel, minus 5 over 5 over x squared minus 6 over x and minus 2. All right, as x is approaching infinity or negative infinity. As we're approaching infinity, all these fractions here are zeros. So I have a minus 5 over a minus 2. Minuses can cancel out. So y is going to be approaching 5 over 2 or 2.5. Okay? If I put in negative infinity, the same fractions cancel out and I still have the minus 5 over 2. That is also going to be approaching 5 over 2. So I do have a horizontal asymptote at y equals 5 over 2 or 2.5. And question 4, I know we've done a few of these now, but question 4 is interesting because there are 3 to the power of x's in there. Okay, so they're going to be a little bit different. So find any horizontal asymptotes of that equation. Okay, always as x is approaching a positive infinity. Actually, I'm going to start with negative infinity because that's the easier one. The positive infinity is a little bit harder. Because if I sub in that x is equal to negative infinity, the numerator, yeah, the 3 to the power of negative infinity is basically 0. Yeah, Tom?
Are we subbing negative?
Just choose a really big number. So you could actually just type in 3 to the negative 100.
A really small one.
Oh, yes, okay. The infinity part is the 100 minus if you need the negative number. Okay? So this part here, if x is negative really big number in that power, boys, that whole first term there is going to be 0, and so that would be approaching 1. Similarly, if I want the denominator, 3 to the x minus 1, again, the 3 to the x, if that's a negative infinity in that power, that first term is going to be 0, so that would be approaching negative 1. So that means my y, the numerator is approaching 1, the denominator is approaching negative 1, so that should be y is approaching negative 1.
Miss, wouldn't it be infinity? Infinite?
Not if it's a negative power, so I did the negative one first. I said that was the easy one, so I did that one first.
But the positive one would be.
The positive one's a bit more complicated, yes. So this involves a bit more work. Shh. If I want to do when x is approaching positive infinity, because 3 to the power of infinity would be an infinite number that doesn't tell me much, what I have to do is divide everything through by 3 to the power of x. Enough. So let's rewrite the equation. That would be y equals 3 to the power of x divided by 3 to the power of x will be 1. 1 divided by 3 to the power of x would be 3 to the power of negative x, could be 1 over. I just want to bring it up. Yes, still with me? On the bottom, 3 to the power of x divided by 3 to the power of x is 1. And minus 1 divided by 3 to the power of x would be bringing that up again to be 3 to the negative x. Okay, now that I have negative powers in there, I can now sub in as x is approaching infinity. My numerator will be 1 plus 3 to the negative x. That's going to be approaching the 1, because the 3 to the negative infinity is going to be 0 again. And the 1 minus 3 to the power of negative x, that's also going to be approaching 1, because I'm minusing off nothing. Okay, so this time y is approaching 1 over 1, which is going to be approaching a positive 1. So there is actually 2 asymptotes here. What's that?
Why do we have to divide by 3 to the power of x?
Because I needed to have, I wanted to have a negative power in here of that x, because that part would be approaching 0. Otherwise, I would have had infinity divided by some kind of other infinity, and I wouldn't have known what numerical number that would have been.
So whenever you do the denominator, divide by it.
Yeah, for that type of question, yes.
So when you approach negative infinity, you don't change anything? Because you still got the initial...
Oh, no, I didn't need to change anything for that one, because subbing in the negative infinity meant that I had a negative big number as my power, which was the 0 that I was after. Shh, guys, patience, please. That we all need. So, as y is equal to negative 1 is a horizontal asymptote on the left. And y equals a positive 1 is a horizontal asymptote on the right. And I drew that because I know that's hard to visualize. I put that in Desmos as well. That's it there. So you need to zoom in. It looks just like a harmless little hyperbola, which it is, but these, the more I zoom in, the more you can see it. These ones here aren't coming all the way down to 0 like our normal hyperbolas do. They're coming down and they're going to be approaching that 1 on this one, and on this one they're approaching negative 1. So 2 different horizontal asymptotes for each side of the graph.